Hello everyone. Today we're going to study how to solve this problem. Find the value of the following series. So our first series is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 up to 1 over 99 times 100. So our denominators are 1 times 2 and then 2 times 3 and then 3 times 4 and then 99 times 100. For our first fraction, we can simply rewrite that as 1 over 1 minus 1 over 2 or 1 over 1 minus 1 half, because the common denominator of these two will be 2 or 1 times 2, and then the numerator will be 2 minus 1 or 1. Okay, so the first fraction is equivalent to 1 over 1 minus 1 over 2, and also the second fraction is equivalent to 1 half minus 1/3. And similarly, the third fraction is equal to 1/3 minus 1/4. And this continues up to 1 over 99 minus 1 over 100. And as you can see, we can cancel out positive 1 half and negative 1 half, positive 1/3 and negative 1/3, that's 0. And also this negative 1/4 will cancel out with the next fraction, which is surely positive 1/4. And then this 1 over 99 will also cancel out with the preceding fraction, which is negative 1 over 99. And we will be left with 1 over 1 minus 1 over 100, or that would be 99 over 100. So that is our answer for our first example. Now let's go to our number 2 example. For number 2, 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 up to 1 over 99 times 101. Okay, to solve that problem, we're going to erase all these. We can rewrite again the problem. Let's copy it again. 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 up to 1 over, what is it, 99 times 101. So as you can see, our denominators are only odd positive integers, 1, 3, 3, 5, 5, 7, 99 to 101. For our first fraction, we can evaluate this. If we use the method as we used in number 1, what would be the value of 1 over 1 minus 1/3? That one would be equal to 2 over 1 times 3. So to make it equal to 1 over 1 times 3, we're going to multiply that by 1 half. Okay? Similarly, the second fraction can also be written as 1 half of 1/3 minus 1/5. And the third fraction, 1 half of 1/5 minus 1 over 7. And the last fraction can be written as 1 half times 1 over 99 minus 1 over 101. Since every term has is a factor of 1 half, so we can factor out 1 half outside, and inside the parentheses will be 1 over 1 minus 1/3 plus 1/3 minus 1/5 plus 1/5 minus 1 over 7, 1/7, up to 1 over 99 minus 1 over 101. And this one cancels with that. These two cancel out, cancel, and 1 over 99 will also cancel out with negative 1 over 99. And we will be left with 1 half times 1 over 1 minus 1 over 101. And that would be equal to 1 half of 101 minus 1 So 1/2 of 100 over 101. And our final answer is 50 over 101. Okay, so that is our solution for problem number 2. Now what if our denominators are only even, consecutive even positive integers? Just like this one, number 3. 1, sorry for that. Number 3 is 1 over 2 times 4 plus 1 over 4 times 6 plus 1 over 6 times 8 up to 1 over 98 times 100. So let's rewrite our problem here. Let's use another color. Let's use black. Number 3 will be 1 over 2 times 4 plus 1 over 4 times 6 plus 1 over 6 times 8, and the pattern continues up to 1 over 98 times 100. Okay, so let's examine again now what happens if we rewrite the first fraction as 1/2 minus 1/4. That would not be equal to 1 over 2 times 4, because this would be equal to 2 over 2 times 4. So to make it equal to the given fraction, again we multiply it by 1/2. So everything else will be multiplied by 1/2. So this third fraction is equal to half of 1/6 minus 1 over 8, and the pattern continues, and the last fraction will be 1/2 of 1 over 98 minus 1 over 100, and we factor 1/2 outside. Inside would be 1/2 minus 1/4 plus 1/4 minus 1/6 plus 1/6 minus 1/8, and so on up to 1 over 98 minus 1 over 100. And we will be left with, inside the parentheses, we will be left with 1/2 minus 1 over 100, and all multiplied by 1/2. So we will now have the common denominator here is 100 divided by 2, that's 50. 100 divided by 100 is 1, so times 1 is 1. So that would be 49 over 200. So that is our final answer. Okay, let's go to the fourth problem. 1 over 1 times 2 times 3. So this time our denominators now composed of 3 consecutive natural numbers, or 3 consecutive positive integers. So how do we find the sum of the fourth series here? So again, let's rewrite our problem. Let's erase all these. We are now in problem number 4. 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4. And the pattern continues to, let's look again, 1 over 99 times 100 times 101. Okay, so how do we find the sum of this series? Okay, let's examine now the first fraction. Okay, so what happens if we rewrite that one as 1 over, so let's group the 3 consecutive natural numbers by 2. So the first group will be 1 times 2 minus the second group will be 2 times 3. So what happens if we rewrite the first fraction like that? Are they equal? Okay, let's check. The common denominator of this now will be 1 times 2 times 3. That's correct. And then if the common denominator is divided by 1 times 2, we are left with 3. 3 multiplied by 1, that's 3. Okay? And then common denominator will multiply by 2 times 3, that's 1. 1 times 1 is 1. And then 3 minus 1 is 2. So the numerator will be 2. It will not be 1. So to make it equal to 1, we multiply everything by 1 half. Similarly, second fraction will be 1 half of 1 over 2 times 3 minus 1 over 3 times 4. And this pattern continues up to the last term, 1 half of 1 over 99 times 100 minus 1 over 100 times 101. And then everything is a product of 1 half, is factor of 1 half. So we factor out 1 half, and then inside will be 1 over 1 times 2 minus 1 over 2 times 3 plus 1 over 2 times 3 plus 1 over 3 times 4. Minus 1 over 3 times 4, and so on up to 1 over 99 times 100 minus 1 over 100 times 101. Okay, so these two now cancel out. That one would cancel with the next fraction. This one will cancel with the previous fraction. So we are now left with 1 half of 1 over 1 times 2 minus 1 over 100 times 101. So inside the parentheses, the common denominator is 100 times 101. So 100 times 101 divided by 2 is 50 times 101. And then this common denominator divided by 100 times 1, that's 1. That's 1. Okay, so we will now be left with numerator of 5050 minus 1 is 5049 over the denominator will be 10100. Then that fraction is multiplied by 1 half. So our final answer will be 5049 over 10,100 times 2, that's 20,200. Okay, so that is our final answer. Now let's go to the next problem. What if the denominators are only odd natural numbers, consecutive odd positive integers? So let's rewrite again our problem. Erase all this. We are now in problem number 5. Let's use another color. Let's use now blue color. We are now in problem number 5. 1 over 1 times 3 times 5 plus 1 over 3 times 5 times 7 plus 1 over 5 times 7 plus 9, and the pattern continues to 1 over 99 times 101 times 103. So how do we solve this problem? Okay, so let's examine the first fraction here. What happens if we rewrite that one as 1 over 1 times 3 minus 1 over 3 times 5? Would that be equal to the given fraction? The answer is no. Sorry. It would be equal to 2 over 1 times 3 times 5. So, not 2, but 4. Because the numerator now will be mm, 1 times 3 times 5 divided by 1 times 2, that's 5. So 5 minus 1, that's 4. So to make it equal to the given fraction, we multiply all this by 1/4. Okay, because it will cancel out the numerator of 4. Similarly, the second fraction can be written as 1/4 of 1 over 3 times 5 minus 1 over 5 times 7. And this pattern continues up to the last fraction, 1/4 of 99 times 101 minus 101 times 103. And then we factor out 1/4, and inside the parentheses would look like this now. Okay, and then our last fraction will be negative 1 over 101 times 103. Okay, so this one cancel with this, cancel, this one cancel with the fraction before it. So we are now left with 1/4 of 1 over 1 times 3 minus 1 over 101 times 103. Okay, so our fraction now can be simplified as 1/4 times our common denominator will be 3 times 101 times 103, and the numerator will be equal to 101 times 103 minus 3. Okay, and that simplifies to 101 times 103, that's 10,043, 10,403, I mean, minus 3, and the denominator will be equal to 31,209. So we are now left with 10,400 over 31,209, all multiplied by 1/4. So 10,400 divided by 4 is 2,600 over 31,209, and that is our answer. Okay, now let's go to the sixth problem. Problem number 6. What if the denominators are only consecutive positive even integers? So how do we do that? Okay, let's erase all these again. We are now in number 6. Okay, 1 over 2 times 4 times 6 plus 1 over 4 times 6 times 8 plus 1 over 6 times 8 times 10. And the pattern continues to, let's look again, 200 times 202 times 204. So how do we solve this? First, let's examine the first fraction. What if we rewrite that one as 1 over 2 times 4 minus 1 over 4 times 6? Would that be equal to the given fraction? The answer is no. That one would be equal to 4 over 2 times 4 times 6. You can verify that by yourself. So to make it equal to the given fraction, we multiply again that one by 1/4. So everything else multiplied by 1/4. So outside we write 1/4, and then inside would be 1 over 2 times 4 minus 1 over 4 times 6 plus 1 over 4 times 6 minus 1 over 6 times 8, and so on up to 1 over 200 times 202 minus 1 over 202 times 204, close parentheses. And that one cancels with that. Cancel, cancel. We are now left with this. Okay. So our common denominator now will be 202 times 204. Okay, so 202 times 204 divided by 8. 202 times 204 divided by 8, that's 5,151 minus 1. So that would be equal to, 5150, sorry, over 202 times 204 is 41,208. Okay, so 5150 divided by 4 is, you can't, let's divide this by 2 first. So 5150 divided by 2 is, oh sorry, I think we cannot, I think we better this one divide by 2. So 5150 divided by 2, 2575. And 4 divided by 2 is 2. So that one now is equal to this. And then the final answer will be 41,208 times 2, 82,416. Okay, so that's our final answer. Now let's go to our last problem. What if the denominators are consecutive natural numbers, but the numerators are not 1 but 8? I think this is very simple. That's very similar with problem number 4. Yeah, problem number 4 and number 7 are similar problems, except that in number 7 the numerators are 8. It means that would be equal to 8 times our answer in number 4, right? So let's solve that one. Let's erase all this again. Number 7, 1 over 1 times 2 times 3, plus, 8. 8 over 1 times 2 times 3 plus 8 over 2 times 3 times 5 plus 8 over 3 times 5 times 7, and the pattern continues to 8 over, let's check again, 99 times 100 times 101. Okay, so we factor out 8, and then first fraction now is this, and the second will be this, third, and the last. But we already solved this one. As I have said, this the series inside the parentheses is exactly the number 4 problem, right? Number 4 problem. Okay, so we can rewrite everything inside the parentheses now as 1/2 of 1 times 2 minus 1 over 2 times 3 plus 1 over 2 times 3 minus 1 over 3 times 5 plus 1 over 3 times 5 minus 1 over 5 times 7. The pattern continues. Minus 1 over 100 times 101. And then don't forget the 8 outside. So it will be 8 times 1/2 or 4. 4 times the first, everything inside will be left now with 1 over 1 times 2 minus 1 over 100 times 101. So this now simplifies to 100 times 101 is our common denominator. So 50 times 101 minus 1. So our numerator will be equal to 5049 over 100 times 101. So times 4. So cancel the 4 and 100. So 5049 over 2525 is our final answer. Okay, so this sums up our studies on how to solve problems that involve series that look like this. So thank you for watching.